You already know how to solve systems of linear equations by graphing. In this video, you will learn a second method for solving a system of linear equations, which is called the substitution method. You will always be able to solve a substitution method problem if you follow this series of steps. So if I ask you to find the solution to a system by substitution, the first thing you should do is choose one equation and solve it for one of the variables in the equation. So I could pick either the first equation or the second equation and solve either of them for A or B. In this case, all of those would be pretty decent ideas, except probably solving this equation for B. Because in order to solve any of the other ones for the variable, because they have a coefficient of 1, you just have to do one step to get that variable alone. So either add to B here, or subtract B, or subtract A. You want to try to make it as easy as possible. So say I decided to solve the second equation for B. So we're making a choice solving for B here that's only going to take one step to get it alone. So I am subtracting A on both sides, which gives me B equals 16 minus A. If you can make a choice that only takes one step to get B alone, you want to make it. You shouldn't make any other choice. Once you've done that, your second step is where this method gets its name. You're going to substitute the expression for B you just found into the other equation to create an equation that only has one variable in it. So what I mean is that we know that B equals 16 minus A. So we're going to take 16 minus A and we're going to put it in to this other equation where we see the B. So what I mean is I'm going to take A minus 2, and then instead of putting in a B, I am going to put in my 16 minus A. Because by solving this first equation for B, we realize that B and 16 minus A are the same thing. And now, this is just an equation that has all A. And in fact, that's our next step. We're going to solve the new equation to find the value of one variable. So the first thing I need to do is distribute my negative 2. So negative 2 times 16 makes negative 32, plus 2A equals negative 17. If I combine like terms, I get 3A, that should be a minus 32, equals negative 17. I'm going to add 32 on both sides. And what I'm left with here is that 3A equals 15. I'm going to come up here to finish. I need to divide both sides by 3. And I will get my answer of A equals 5. So now that we know that A equals 5, we need to figure out what B equals. To do that, we're going to substitute the value for A that we just found into the other equation and solve for B. So what do I mean by the other equation? So what I mean is that we just used this one, because that's what we put the 16 minus A in. So we're going to substitute our A into this equation. So using A plus B equals 16, which is the one we weren't just using, we're going to put A in as 5. So we'll have 5 plus B equals 16. And then to solve for B, all I have to do is subtract 5 on each side. And I end up getting that B is positive 11. Now we're almost done. Our last step is to write our solution. And so the solution should be an ordered pair, x comma y. But in this case, we have A and B, not x and y. So what you're always going to do is just write it in alphabetical order. So since we have A is 5 and B is 11, we're going to put 5 comma 11. And this makes sense because we have learned previously that the solution to a system of linear equations is always a point. So this would be the point where those two graphs intersected, and we found it algebraically instead of by graphing. Once you've found your solution, a smart thing to do is to check it. And you want to check it by plugging it back into the equation that you didn't just use to solve for the second variable. So if you remember, we just used A plus B equals 16 to solve for that second variable. So we're going to switch back to the other equation and use this one. So what we're going to do is we're going to plug in 5 for A minus 2 times 11 for B and see if that equals negative 17. So that's going to give us 5 minus 22 equals negative 17, and 5 minus 22 is negative 17. So since that comes out even on both sides, that means our solution works. Now I'm going to start a second one, and I'm going to have you finish it on your own. So our second example is find the solution to the system. So you know that your first step should be to choose one equation and solve it for one variable. So in this particular problem, you should take this first equation and solve it for y. And we would want to choose this equation for y because this one y is the only variable in the system that does not have a coefficient. So when I take 7x plus y equals 8 and solve it for y, all I have to do is subtract 7x. And you want to do this so that you only have to do one step to get the y by itself. So what I have here is that y equals 8 minus 7x. So that's our first step done. Now what you should do is go back to our first example and follow all of the steps that we did in that example to finish solving this system. Best of luck, and we'll talk about this more in our next class.